Hello students, welcome to the subject of Mathematics 3 for all my mechanical engineering students, myself Dr. Ankit Acharya, and as you all know that in last lecture we discussed about our new chapter unit number 7 higher order ordinary differential equation, and in previous lecture we discussed about how we can solve homogeneous system of linear differential equation, and after that we discuss about very important method undetermined coefficient. Okay, so today we will discuss about method of variation of parameter. Okay, so in this method of variation of parameter, see how this type of differential equation d square y by dx square plus a1 dy by dx plus a2y that is equal to qx. Okay, most probably this method we apply for second order ordinary differential equation. Okay, so d square y by dx square plus a1 dy by dx plus a2y that is equal to 0, and this formula that you have to remember. Okay, complementary function we find with the same method as we find in previous examples. Okay, but particular integral, now what is your particular integral here? Here you can see that this u, first we find u. Okay, u is what? Integration minus y2q upon w dx. Okay, and what is your v? V is what? Integration y1q upon w. Now what is w? W is our Wronskian determinant. Okay, w is what? Wronskian determinant, right? Now w, where w is, okay, w that is equal to determinant of y1, y2, y1 dash and y2 dash. Okay, and u is equal to particular integral that is equal to c1u plus c2v. Okay, where u is equal to, okay, u is equal to minus integration y2q upon w dx, and v is what? Integration y1q upon w dx. Okay, y1 and y2 is what? Y1 and y2 are the solution of homogeneous linear system of equation. So but always first we find complementary function. If your differential equation is a second order differential equation, then your complementary function is like c1 y1 plus c2 y2. Okay, so whatever the function with multiplication of c1 with multiplication of c1, that is y1. Okay, and multiplication of c2, whatever the function with multiplication of c2, that is called y2. Clear? So y1 and y2 is clear. W is Wronskian determinant, which we can find from y1 and y2, that is nothing but determinant of y1, y2, y1 dash, y2 dash. Okay, q is right side whatever the function, this is your q, the right side of function. Okay, so that is your q. Now y double dash minus 3y dash plus 2y that is equal to e raised to x. First I want to solve this example. Okay, so of course we write with this form d square minus 3d plus 2 into y that is equal to e raised to x. So m cube, okay, m square, sorry, this is m square, printing mistake, m square minus 3m plus 2 that is equal to 0. Factorization, that is clearly m minus 2, m minus 1 is a factorization, so m is equal to 1 and 2, real and distinct root. So that's why what is your complementary function? Complementary function is c1 e raised to 1 into x plus c2 e raised to 2 into x. Clear? So c1 e raised to x, okay, plus c2 e raised to 2x. So clearly what is your y1? Y1 is e raised to x. What is your y2? Y2 is e raised to 2x. And Wronskian determinant, suppose I want to find Wronskian determinant, that is y1, y2, y1 dash and y2 dash determinant. Okay, y1, y2 that is e raised to x, e raised to 2x. Okay, and differentiation of e raised to x, that is e raised to x, differentiation of e raised to 2x, that is 2 e raised to 2x. So e raised to x into 2 e raised to 2x, so 2 e raised to 3x. Okay, second order determinant, so 2 e raised to 3x minus e raised to 3x, so this equal to e raised to 3x. Clear? So Wronskian determinant is e raised to 3x. y1 is e raised to x, y1 is e raised to x, y2 is e raised to 2x. Clear? Wronskian determinant is e raised to 3x, and q is what? Right side, what is our function? Q is e raised to x. Okay, so that is e raised to x. Now first so particular integral that we know that u c1 into u plus c2, okay, c1u plus c2v, right? So let particular integral u is equal to, first we have to find u, right? So u is equal to integration minus y2q upon w. What is your y2? y1 is e raised to, let first find all the information. Y1 is e raised to x, y2 is e raised to 2x, q is here Wronskian determinant, w is equal to e raised to 3x. Okay, and put all this value in this equation. So integration minus y2, so u is what? Minus integration y2 is e raised to 2x, q is e raised to x, okay, upon w is e raised to 3x, okay, and dx. So e raised to 3x, e raised to 3x upon e raised to 3x, so that is equal to minus x, integration of 1, that is minus x. Okay, similarly we can find v, right? So that is minus e raised to minus x, okay, and we know that particular integral, right? See here you can see that integration e raised to x upon e raised to 3x, so e raised to minus x, integration of e raised to minus x, that is minus e raised to minus x. So particular integral we know that c1u plus c2v, okay, what is your u is minus x, so c1 into minus x plus c2 into minus e raised to minus x, so minus will be common, minus, okay, and minus x, okay, x e raised to x, so minus x plus 1 into e raised to x, that is your particular integral. Okay, now working rule, as I told you, that find the complementary function c1 y1 plus c2 y2, right? First we find Wronskian determinant, okay, and assume the particular integral u y1 plus v y2. Find u and v by evaluating the integral. U is equal to minus y2 q by w dx, and v is what integration y1 q by w dx. Substitute u and v in particular integral, write the general solution, that is complementary function plus particular integral. Okay, suppose in some time they ask only about Wronskian determinant, so find the Wronskian determinant only, okay, of for this equation. So y double dash minus 2y dash plus y is equal to 0. So clearly this is your f of m, okay, f of m is what? M square minus 2m plus 1, so m minus 1 whole square, that is equal to 0. So m equal to 1 1, right? Real and repeated root, okay. c1 e raised to x plus c2x e raised to x, that is your complementary function. So y1 is e raised to x, y2 is x e raised to x, okay, y1 y2 y1 dash y2 dash. So clearly y1 Wronskian determinant, that is y1 y2 y1 dash y2 dash, that is equal to e raised to x, here you will get x e raised to x, okay, differentiation of e raised to x, that is e raised to x, differentiation of x e raised to x. So for that you have to use multiplication rule. So e raised to x, differentiation of x is 1, e raised to x as it is, plus x is as it is, differentiation of e raised to x, that is e raised to x. Okay, so when we calculate this, e raised to 2x, e raised to x into e raised to x, so e raised to 2x plus x e raised to 2x minus x e raised to 2x. Okay, so this 2 will be cancelled out and answer is e raised to 2x. Okay, so this just we find Wronskian determinant. Let's take one more example, d square plus 1 into y, that is equal to cosec x. So first we find complementary function, m square is equal to minus 1, because f of m is what? M square plus 1 is equal to 0. So clearly m square is equal to minus 1, so m is equal to plus or minus I, okay, because from this you can say that m is equal to plus or minus square root of minus 1, and square root of minus 1 is I. Okay, so m is equal to plus or minus I. When we compare this with alpha plus or minus I beta, so what is your alpha? Alpha is 0 and beta is 1. And what is your complementary function? Complementary function is e raised to alpha into x, okay, into c1 cos beta x plus c2 sin beta x. So when we put this two value, okay, that is e raised to 0 into x, so 1 c1 cos x plus c2 sin x. So cos x sin x, these two are cos x and sin x are now your y1 and y2. Okay, so y1 is cos x. We can say that here you can see that y1 is cos x. Just I write here y1 is cos x and y2 is sin x. Okay, here and w Wronskian determinant. If you want to find Wronskian determinant, that is cos x sin x, differentiation of cos x, that is minus sin x, differentiation of sin x, that is cos x. Okay, so cos square x plus sin square x. So Wronskian determinant we will get 1. Clear? And now put all this value in this equation. So u is equal to, see, u is what? U is equal to minus y2q. U is equal to integration minus y2q upon w dx. Clear? All information are clear. Y2 is sin x, so y2 is sin x. Q is what? Q is this function cosec x, so q is cosec x. Wronskian determinant is 1, so dx. So sin x into cosec x, that we know that 1, so that's why okay, this is integration of 1, so minus x, because minus is already outside the integration, so u is minus x. Now suppose we find v. Okay, clear? U is clear, so u is minus x is clear here. Now suppose we find v. V is what? Integration y1 q upon w. Okay, what is your y1? Y1 is cos x, q is cosec x. Okay, and w is 1. Okay, w is 1. So cos x into cosec x. Cosec x means what? 1 upon sin x, and cos x upon sin x, that is cot x. So integration cot x dx, so that is equal to cos upon sin. So integration of cot x, that we know that log sin x. Okay, log mod sin x. So just I write log sin x. This is your v. Okay, so u is clear, v is clear, and particular integral is just c1. C1 into u plus C2 into v. Okay, and just don't forget to write down the general solution, that is complementary function plus particular integral. What is your complementary function? Complementary function is C1 cos x plus C2 sin x, and particular integral is this one, minus x cos x plus log sin x into sin x. Okay, so in today's session we just discuss about very important method of variation of parameter, and this method generally we use only for second order differential equation. Okay, so thank you.